Alright, so for the first one, the temptation is to take the square root first. Because it's like the square root of 9 is 3 and the square root of this is k plus 1, but that's ruining the fun. So always in math, the order of operations is in play. And when we're solving, we have to do the inverse operations, right? Exponents are all the way down here. Multiplication comes first. So we have to do the opposite of times 3 first. I mean, there is a way to do it right otherwise, but it's kind of ugly. So this will keep your things more simple and clean. So this is the better way. Yeah? 9 divided by 3 is 3, I hope. Yeah? Square root both sides? Washa. K plus 1 equals plus or minus the square root of 3. So k, now you're going to subtract 1, plus or minus the square root of 3. Now if we were using a calculator for the square root of 3, right, then we would have to figure out our two answers, right? So you'd do negative 1 plus the square root of 3, and you'd see what that equals, and you'd do negative 1 minus the square root of 3. And you'd see what that equals, and that's how you get your two answers. Yeah? But for what we did right now, done. So, Jose, I'm curious. Did you get it right? No. No? Did you do the square root first?
No, I was doing something.
Oh, you squared it and distributed and moved the 9.
When I first I did the 3 into the k plus 1.
Oh, you violated the order of operations.
And then I extended it.
Yeah. So, Jose, if you were going to like try that method, you would have to square before distributing, because like if you were going to do it that way, then you would be using you would just be like simplifying it, right, which is the order of operations. So you would have to do the exponent first, and then you would have to multiply. But
so then I did that.
you would end up with this. You would end up with k squared plus 6k plus 3 equals 9 is what you would end up with.
Yeah, I did that the second time.
Yeah.
Still not the right answer.
And then you'd go through all kinds of work, and then you would end up having to complete the square. Like here you could divide everything by 3 actually.
Yeah.
And you could end up with k squared plus 2k plus 1 equals 3.
I have one question. So, the minus 1 came from removing the k plus 1, right? To the other side? The plus 1 to the
This
other
one
side?
right here?
Yeah.
Yeah.
Alright.
Okay, good. So the clue is, like, since it's already like a square root and we're solving for k, all we really got to do is get rid of this square. So sorry, since it's a square, and the square is what's keeping k from being that by itself. If you can get this thing by itself, then you can do the square root and you're done. A little easier. So that's why this is a good practice problem, because yeah, experience. So like this one's almost the same, except there's no coefficient, there's no number in the front, so all you gotta do is take the square root, right? And then you're gonna be left with x minus 2/3 equals the square root of 5 over 3. But here's the thing about this, Edgar. Make sure that you don't write this wrong. Don't confuse yourself. Like here's what people write all the time. They write like this, and that's different. That's the square root of 5/3. This is the square root of 5, and then that and number, whatever the square root of 5 equals, that number is being divided by 3. So totally different. Totally different.
5 divided by 3.
Right.
So which one's the correct one?
This is what we're doing, because we took the square root of 9 and it's 3. Yeah. All right. So you got to add this to both sides. They have the same denominator, right? And so for what we've done so far, that's it, right? 2 plus or minus the square root of 5 divided by 3. Now, if you were using a calculator to come up with like a decimal approximation, here's what you would do. You would do it for both things. You would say 2 plus the square root of 5, and then you divide that by 3. That was one answer, right? And then 2 minus the square root of 5 divided by 3. That little thing right there, that's what it means. It means you have both. It means you have both of them. You have one where you're adding the square root of 5 and the other where you're subtracting it. How you doing over there, Ivan? You alright?
Almost right.
Okay. Tired? I'm tight.
Yeah, I can finish the class. Yeah.
Well, yeah. You'll soldier through. You're young. You can handle this. You can handle this. And questions about the second one before we move on to the third? No?
It was pretty easy. I think it was easy as well.
This one's tricky.
Yeah.
This one's tricky because you kind of have to be aware of what you're trying to do. We're trying to solve for the unknown q, right? And so what would be easiest is if you could move the 16 over here and it would end up being factorable. So like I did this in my head. Like I moved 16, like, so I had negative 16, right? Plus 9, and negative 16 plus 9, isn't that negative 7?
Yeah.
Right? So if this is factorable, then life is good.
But it's not.
So I don't know, maybe. In order to be factorable, you have to have two numbers that multiply to 7, and then the same two numbers add to 6. And they're different sign. What about
7 and -1.
you see? I think that's right. So let's make sure. Is 9 minus 16 really equal to negative 7? I mean, that's the kind of thing that I would, if I was taking a quiz, that's exactly the kind of thing I'd screw up. I hope so. Okay. And so then I would just double check this. So get q squared, good. The outside is plus q, the inside is minus 7q. Plus q minus 7q is minus 6, yeah? And that makes negative 7 right there. So now you just have to take each of these factors and set them equal to 0. Solve each one. So your two answers are q equals positive 7 and q equals negative 1. Those are your two answers right there. Done. So that one was tricky because you might have been tempted to complete the square.
Yeah.
But it was
I was
factorable.
tempted to
It was factorable. In fact, if you complete the square and you end up with two integer answers, then that means it was factorable all along. Actually, even if they're fractions, but they're rational, like 2/3 or something, not square roots, then it was factorable all along. So the moral of the story: see if it's factorable first. If it's factorable, you don't want to use the quadratic formula. You don't want to complete the square. You just want to factor because that's easy. Yeah. Other questions on these three? No? All good. All 100%.